Everyone, in this video we're going through quadratic equations and parabolas. So looking at the equation of a quadratic, maybe the graph, which is the parabola, looking at the quadratic formula, the discriminant, using completing the square to put a quadratic into turning point form, and other features. I don't know. We'll get through them all. If this video does start becoming too long, I'm going to just shorten it. So do keep in mind that some of you, we would have covered this in class, but for others, we wouldn't have done it, depending on which class you're in. Anyway, let's make a start. So a quadratic graph. So hopefully you're familiar with a quadratic graph because you've done it since year 10, maybe even in year 9. All right, so let's draw a quick quadratic graph just to refresh your memory. All right, so there's your quadratic, your basic quadratic graph. All right, it's just like a U shape, or it could be reflected in the x-axis and it would just be upside down. We call it reflected. Now, when you're factorizing quadratics, if it's an easy one to factorize, then you don't need to use the quadratic formula, but the quadratic formula will solve absolutely any quadratic. So you can see here, it's in the form ax squared plus bx plus c equals 0. So this equals 0 part is extremely important because that actually tells us our x-intercepts. So remember, when y equals 0, we get our x-intercept. So that's why you often see things equal 0, or we let it equal 0. Now here's your quadratic formula here, which is pretty straightforward. Just be careful with any negatives. So you can see in my example, we've got a value of b, which is -3. So when you're substituting it in, especially with any negative numbers, just put them in brackets. All right, so that's just going to prevent you from accidentally, for example, this one here, this -3 squared, because it's you're squaring a negative number, it becomes a positive. So you just want to be careful with things like that. All right, so quadratic formula you've done before, so I'm not going to spend too much time with that. This other formula down here is just the x-coordinate of our axes of symmetry. So what an axis of symmetry is, let me go back to Desmos, and I'm just going to draw it on here because I've got my computer's flipped down and it's just a little bit awkward to keep flipping it. So axis of symmetry just means you've got a straight line, horizontal line going through your parabola so that it's symmetrical on either side. So the equation of this, this line is x equals 0. But if we wanted to get this turning point, we can use, where are we? I'm just trying to find where I've written it. Oh, here's the rule here again, but we can just substitute it in, where am I? All right, here. So your turning point, when you substitute in -b/2a, we get 3/4. And then to get the, sorry, I'm jumping ahead. So that's the x-coordinate of the turning point, and your axis of symmetry equation is x equals 3/4, all right, because it's a straight vertical line. And your turning point, and I don't think I wrote it on here, let's just go down. So remember, your turning point has coordinates, so it's 3/4 and -6 1/8. All right, so that's the coordinates of your turning point. So the formula up here, the -b/2a, just gives you your x-coordinate of your turning point, or the equation of your axes of symmetry. Then once you got your x value, you do need to substitute it into your equation to get the y-coordinate. So that's what's happened down there. So if I just quickly, just using this one as an example, sorry, I'm all over the place. Hopefully you haven't got motion sickness. So 2x squared, sometimes I need to write this down. So 2x squared minus 3x minus 5. So let's put that into Desmos so I can show you. 2x squared minus 3x minus 5. And just pop that down so you can see it's shifted. And so your axis of symmetry, remember we worked it out to be x equals 3 over 4. Let me just delete that. All right, and you can see there's your blue line, which is your axis of symmetry. It is an equation, so the equation is x equals 3/4, as I've got on the left side. And then you can see here your coordinates of your turning point. All right, they do have them converted to a decimal, but it's the same thing as 3/4 and -6 1/8. All right, moving along. Actually, there was one thing I wanted to say. On this year's exam, I don't know whether I said it earlier, so sorry guys if I'm repeating myself. On this year's methods exam, Year 12 methods exam, there was a question that required you to use that formula. And when I saw that question, I was like, oh my gosh, I hope they remembered that that formula exists, and it's so much easier than, you know, completing the square and getting it into turning point form. And so when the girls got out of the exam, I mentioned that question. They said, oh yeah, negative b over 2a. And I was like, oh, awesome. Because it's not, a lot of things are assumed knowledge in methods, and that's an example that we would have done during Head Start, but probably not really done too much more with it, because there's so much more to learn than just that formula. All right, so moving on to the discriminant. So the discriminant, we use this triangle, and it's b squared minus 4ac. So what you might hopefully noticed, and maybe you've been taught this, that the b squared minus 4ac in your quadratic formula, so I'm just going to quickly write it down here. So the b squared minus 4ac part is actually this part under your square root sign. And that determines how many solutions we have, because we only deal with real numbers. So there is a branch of mathematics called imaginary numbers or complex numbers. So we're only working with real solutions. So we're taking the square root of a number. So let's just call that number x. So x, if x was positive, so greater than 0, actually I might not call it x, let's call it the discriminant, because, all right, let's put that in. If your discriminant was greater than 0 or positive, so that's what the greater than 0 means, that means we're going to have two solutions, because we could have, say, the square root of 4, which can be both positive 2 or negative 2, because 2 squared gives you 4 and negative 2 also gives you 4. So that's why when the discriminant is greater than 0, we can have two solutions. Now when your discriminant, and I'm writing all over the place here, sorry guys, when your discriminant is equal to 0, we have the square root of 0, which is just 0. So that's why you get just one solution there. And when your discriminant is less than 0, basically we're taking the square root of a negative number. Let's just call it negative discriminant, which we can't do. Okay, we can't do the square root of a negative number and get a real solution. Okay, so that's why it says no real solutions. If you think of it in terms of your parabola, what is happening, and I'm going to just see if I can add a slider here. All right, so basically what's happening, see my graph move, let's just move you down here. All right, so at this point our parabola is crossing the x-axis twice. As I go up, all right, still twice, and then it just touches, oops, it's really, you know what I mean. Let's just pretend it's touching there. So it has one solution, and then as soon as it goes over, it doesn't have any solutions because it's no longer crossing the x-axis. And this sort of concept we do explore usually in our first SAC. Now, as I was doing that, I realized maybe we should do that on the calculator, because you can do sliders on your calculator as well. Let's see if the calculator is going to want to open. All right, so just quickly, because you know, if this is on your SAC, we'll definitely do this beforehand. So I'm just going to type in x squared. And then to add a slider, just move that up. Oh, excuse me, can you go up a bit? All right, so to add a slider, we can just go plus, go into your keyboard, and add any letter, obviously not X or Y or Z. So I'm going to do K. All right, so plus K, and tick it because we want it, and it's going to be very, usually my calculator doesn't like being flipped on my computer. All right, so see how we got that error message? So this one next to it, this one here, adds my slider. So did you notice that little K box came up? So I'm going to have to put my graph on. Let's see if we can see a bit easier. All right, let's change the window. All right, so we'll just go from -10 to 10. Come on, cooperate. All right, so there it is. Put our slider back on. Come on. And what this means is I can move it up and down with this slider, just like I did on Desmos. So exploring this graph, sometimes there might be a question that says, for what values of K are there two solutions? And I think we're actually going to do some questions like that. All right, so you can use Desmos to move that up and down. And you should be familiar with transformation, so you can put your equation in the form, oh, I'm getting sidetracked here, but in turning point form, so a times x minus h squared plus k, and put all three sliders in there and move it around. Anyway, getting sidetracked. Let's get back to the question. Okay, so sorry, I was just reading where we're actually up to because I went on a huge tangent there. All right, so these three examples, you have three different types of solutions. So we're just identifying the A, the B, and the C, and substituting them into the discriminant. So basically, we're just looking whether it's positive in that case. Here it's negative, and here it's equal to 0. So you can see we've got two solutions, no solutions, and one solution. All right, so that should all be revision for you. So let's quickly move past it. All right, completing the square and the turning point. So as I said before, this is your turning point form. And turning point form is good to see the transformations. So, and the turning point, obviously. But you can get the turning point without completing the square. So remember what we did earlier, with this formula here that I've circled so many times already. You can get the x-coordinate of the turning point there. You don't need to put it into turning point form to get the turning point. What am I doing? All right, so completing the square is vital if you're looking for, oh sorry, I shouldn't say it's vital, but if you want to read straight away your transformations without doing any mapping, it's probably a good idea just to put it into turning point form. All right, so your turning point, whoops, let's go back up here. All right, so to get it into turning point form, we do need to complete the square. So hopefully you've done this so many times that it is quite natural to you. So here's our first example, y equals x squared plus 4x minus 3. Now you could factorize this. You could think of two numbers that multiply to give you 3 and add to give you 4. But if you can't think of integers, so this one here, it does not work with any two integers, then you could use the quadratic formula. Or you could complete the square. So here we're going to complete the square. What I was going to say with factorizing, anyway, sorry, I'm going off track again. Stay on track. All right, I'll talk about that later. X squared plus 4x minus 3. So what we do is we look at this coefficient of x and we divide it by 2. So you can see that's what I've done here. So we keep the x squared plus 4x the same, so that stays the same. Then we add 4 over 2 squared, and then we subtract 4 over 2 squared. So effectively what we're doing here is not changing the value of our equation at all, because that is still equal to 0. All right, it's like saying 10 is equal to actually get rid of that. So 5 minus 5 is 0. All right, we just got a number and then we're subtracting it. So if we could say 10 is equal to 5 plus 5, or 10 is equal to 3 plus 7. I could then say, all right, 3 plus 7, let's add 2, take away 2. By adding this on the end, I'm not actually adding anything worth value. It's still 10 equals 10. I'm just writing two numbers so we can complete the square. Anyway, I'm going to get rid of that because I don't like it there. The reason for completing the square is so we end up with this perfect square here. All right, so we'll come back to that in a sec because we haven't finished going through the steps for completing the square. All right, so once we've added b over 2 squared minus b over 2 squared, and then don't forget this minus 3 on the end. So we end up with x squared plus 4x plus 4 minus 4. So that's come from there and that's come from there. Minus 3. When we factorize this, it becomes a perfect square. So the 4 over 2, whatever this number is, just goes here. So 4 divided by 2 is 2. So you can sometimes jump this step. And then we've got minus 4 minus 3 gives you the negative 7. All right, now because I've drawn all over that, and you probably can't see any of the numbers now, let's just rewrite it. All right, so your quadratic in turning point form is here, right up the top. Notice we have the minus h. So that's, just make sure you don't get confused with that. So you'll notice, oh God, we've got a plus 2. So sometimes students just think that's your value of h. Remember, it's got to be x minus something. So we can say then, all right, it's minus 2. All right, so in our rule, we have x minus h. So in this case, h is negative 2. So that's why I've got the negative 2 there for our x coordinate of the turning point. And then the k is the minus 7. I was wondering what this was. Positive parabola. I think that's what it means. Shifted down. Oh, okay. I'm like, what have I written here? Okay, so I thought we were talking about the transformations. Okay, so it's a positive parabola. So it's a U shape. All right, that's been shifted down too. So if you got a positive parabola that's been shifted down, then it's going to cross your x-axis. So if we go back to our calculator, all right, so there's our, whoops, positive, come on. All right, there's our positive parabola. If it's shifted down too, oh no, sorry, it's not shifted down 2, it's shifted down 7. All right, you can see we've got the 2x intercept, so that's what I've written there. Okay, finally worked it out. All right, then we've got another example here. Let me just see how difficult it is. Oh, this is a tricky one. So you can see when you're completing the square, you should always have your leading term, your x squared term, have a coefficient of 1, not negative 1. All right, just positive 1. So you can see I've taken the negative 3 out as a common factor, and which leaves us with x squared minus 3x plus 4. So I've completed the square just with this bracket here. Kept the negative 3 out the front as we go along, and here it is in turning point form. So that negative 3 does tell me that it's been reflected and dilated, but we'll talk about transformations later. Here's our value of h, 3 over 2, so there it is in the turning point. And value of k is 21 on 4. Well, sorry, negative 21 on 4. All right, so what I've written here, it's a negative parabola. I know it's negative because of this negative sign. And it's been shifted down by 21 on 4. So let's turn this into a negative parabola just so I can show you what I mean. And I know it's not the same equation. All right, so let's put you back up. All right, so there it is. K is value. The value of k is greater than 0. So you can see you've got two x-intercepts and it's going down. All right, so once it's gone below that x-intercept, so it has in this case by 21 and 4, you no longer have any x-intercepts. So that's why what I've written here, no x-intercepts. All right, so when you read a quadratic in turning point form, you should, well, if not already, you should eventually get to the point where you can just picture that quadratic and understand what the transformations are and whether there is x-intercepts or not. All right, I might stop there just because I think we probably would have got to that point in class. So I'll do a separate video now for this transformation stuff because it might be a little bit more, a bit of a longer video. All right, bye.